proves that the square of a positive integer can never be of the form 3k plus 2, where k is positive integer. How all possible integers can be represented mathematically? We can consider all possible integers as two groups, odd and even integers, so that we can say that any integer can take one of the following two forms, 2n and 2n plus 1 or minus 1, where n is integer. And in general, if you show that it's true for these two groups, hence it's true for any integer. Or any integer can take one of the following three forms, 3n, 3n plus 1, 3n plus 2, or it can be 4n, 4n plus 1, 4n plus 2, 4n plus 3, and so on. And in general, if you show that it's true for all these groups, it's true for any integer. So here we can see that 3k is involved, so it will be useful to consider all possible integers as three groups, 3n, 3n plus 1, 3n plus 2. So we can say that the number to be squared can take one of the following three forms. n, 3n plus 1, 3n plus 2, where n is positive integer. And we need the square of a positive integer, so let's consider a square of each number. So 3n squared is what? 9n squared, and it's 3 times 3n squared, since n is positive integer. 3n squared it's also positive integer, so we can say that it's 3k, where k is positive integer. And 3n plus 1 squared is what? 9n squared plus 6n plus 1 is, we can factor out 3 here, so it becomes 3n squared plus 2n and plus 1, and it's 3k plus 1, where k is positive integer, and 3n plus 2 squared is 9n squared plus 6n plus 4, and 4 is 3 plus 1, and it becomes 3n squared plus 2n plus 1 and plus 1, and it's, you can see that it's positive integer, so it becomes 3k plus 1, where k is positive integer. So squaring any integer only produces integers of the form 3k or 3k plus 1. Therefore, the square of a positive integer can never be of the form 3k plus 2. And that's all for this question.